Hi, so I thought this was pretty cool and pretty timely for March 26th. Dogs are not happy because they have the best of everything. Dogs are happy because they make the best of everything. Case in point, I open the door. There's snow everywhere. I groan. Oh no, I thought it was spring. My dog says, "Oh, snow, snow. Let's go, Mom, let's go." So I'm trudging, and she's bounding through the snow. It was kind of funny, but anyway, it's kind of true. So let's go over practice 8-1. So number one, is this relation a function or not? So you graph it and you'll go, no. Because see, when I have x is -1, I've got two different y values. So if I plug in -1 for x, I don't know which one I'd get out, right? So that one does not. It fails the vertical line test, right? Because if I come across it with my pen, oh no, two at once, right? So that does not work. So fails the vertical line test, or it has two y values when x is -1. Say it either way. Number two, here's our points. So we graph those points, remembering that first you go left or right, then you go up or down, right? And we'll have more of that in the next lesson. So here's our points. So you come across it with a vertical line, sometimes called a pen or pencil or something like that. Okay, never passed through more than one at a time, right? So it does pass the vertical line test. It is a function, and there's only one y value for every x value, so it works. For the next one, hopefully you did not, make this hard, because it just asks for the domain. Remember, the x values are the domain values. So 7, 8, -5, and -9, those are the domain. If you wanted to put them in order, you can, in which case I go -9, -5, 7, and 8. Either way, it doesn't matter. And then the range values, you can either give them to me in the order given, like -2, -2, 7, 1, or if you wanted to, you could do that -2, -2, 1, 7. This is a function because there's a one-to-one correspondence, which means that every x has only one y. Is there a repeated y? Sure there is, but there's no repeated x with two different y's. That's the key. Number 4, domain values are -8, 10, 10, and -5. You can change the order if you wanted. I just do them in the order they give them to me usually. And the range values in the order given were 0, 6, -2, 7. Then the question is this a function or not? And the answer is no, because there's two different y values when x is 10. So if you look at the actual problem, because sometimes you write them out and it's harder to see than just looking at the problem. If I put in 10, what do I get out? I don't know. I either get 6 or -2, right? As opposed to if I put in -8, I know I'm going to get a 0. If I put in -5, I know I'm going to get a 7. Because there's two of the same x value, 10, with two different y values, then it's not a function. Does not have a one-to-one correspondence. Next one. The x values are the domain, so 9.2, -3.6, and 5.2. The y values are the range, so 4.7, 4.8, and 4.7. There's a repeated y. Is that a problem? No. It's only a problem if there's a repeated x with two different y's, but there's not. So this is a function, and it's a one-to-one correspondence. Now the next one you get to, and you go, I don't even know what they're asking, right? Is the time it takes you to run a 100-meter race a function of the speed you run? In other words, does how long it takes you to run depend on how fast you go? Well, yeah, it does, definitely, right? Because the faster I go, the shorter the time it takes. Now, I am not 100% sure if I had printed on yours page 407, 1 to 5 or not. It was the intention, but I don't know if it was or not. If it wasn't, I'm not going to fret it, but if it was on there, here it comes. Now, I copied the problems just so we could see them, which is really handy now, especially. You didn't necessarily have to. You just had to tell me if it was a function or not, and why or why not. So the first one started with -5, -2, 2, and 5. These guys both went to a -2. These guys both went to a +3, but that's not a problem because any x only went to one y. So it is a function because for every x value, there's only one y value. That one's a function. Contrast that with number 2. In fact, I'll leave the other one showing a little bit. Here I've got an x value of -4 going to -5 and to -1, and an x value of -3 going to 2 and to 6. So this one is not a function because if I stick in -4, I don't know what I'm going to get out for y because there's more than one y for every x. And you might have drawn this with a -4, -4, -3, -3. That's fine too, because then you can see there's more than one of these going to the right. I'll take either diagram form. Okay, then number 3, and I'm just doing them the way the examples were. So 3, if my x is 3, I get -5 for y. If my x is 6, I don't know what I get, because I might get -2, I might get 0. That right there tells me not a function, because this x value has 2 different y values. But if I put in 7, I get a 1. So that one's not a function. Then we go to number 4, and it is listed, just like we did on the ones on the front. So I got 3, -1, 3, 0. No, -3, 4, and 3, 8. Well, there's like 3 3s, and I don't know what I'd get out, right? So it's not a function, because for the x value of 3, there are 3 different y values. So that does not work. No one-to-one correspondence. But number 5, -3, I get -2. If I put in -1, I get 0. If I put in 1, I get 0. If I put in 5, I get -2. And there's no question about those, right? Therefore, it is a function because each x value has only one y value. So there's a one-to-one correspondence. And then in the next lesson, we're going to do more graphing, and we're going to graph some equations. So, see you later.